This is a video on U-substitution. We are asked to find the integral from 0 to 4 of 2x times the square root of 9 plus x squared dx. Our strategy is to use the method of U-substitution. So we seek out a good U, and typical good U's lie inside square roots or in parentheses or trig or exponents. And in this case, we have a 9 plus x squared inside the square root. And notice the derivative of 9 plus x squared is 2x, and that's available for us. So that leads us to the U substitution, U equal 9 plus x squared. As I said, the derivative, du, is equal to 2x, because that's the derivative of 9 plus x squared, dx. So we see we have a 2x dx, that's a du, and we have a square root of 9 plus x squared, that's a square root of u. Our last step in the substitution is to work with these numbers 0 and 4. So first note, if x is equal to 0, then our u, which was 9 plus x squared, is 9 plus 0 squared, or just 9. Also, if x is equal to 4, then our u is 9 plus 4 squared, or 25. So now we could put everything into the integral and substitute. I get the integral, now it's from 9 to 25, because that's where 0 and 4 went under the substitution. Of u to the 1/2, there's our root 9 plus x squared is root u, and the square root of u is the same as u to the 1/2. And then 2x dx is du. So now we have an integral that is pretty simple. The integral of u to the 1/2, we can use a power rule. 1/2 plus 1 is 3/2. So we get u to the 3/2 divided by 3/2, or the same thing as times 2/3. And we're going from 9 to 25. So now we can just plug in. I plug in a 25 for u, I plug in a 9 for u, and then subtract. I get 2/3, 25 to the 3/2, minus 2/3 times 9 to the 3/2. And I subtract those. Notice 25 to the 3/2, square root of 25 is 5. 5 cubed is 125. And also 9 to the 1/2 is 3. 3 cubed is 27. So I worked all that out, and what I ended up getting was 196 thirds. And I'm done with the problem.